Yes, sir.
Yes, sir.
Let's go to the architecture. Okay. So have you seen this video? Yesterday's video, how many people seen?
Yes, sir. Understand.
Have you understood at least 60-70%? Anybody?
Yes, sir.
So this is the architecture select statement. Okay. How the select statement works. You can see select star from EMP. Okay. If we run this, we get the output. Can we run select from star EMP? Is it a right statement?
No.
Okay. So if the syntax is good, then only the statement will be executed. Okay. So that is the meaning of syntax. Whenever you run select star from EMP on the database server, the client process will be created. Okay. The first thing is when you connect to the database using a specific user. Suppose let's take an example SQL plus ABC by password @ some TNS entry. If we connect like that, the first thing is the client process will be created. Okay. Along with that, there is some process is called server process will be created. So what client process will do? The client process will check the syntax of the statement. What client process will do? The client process will check the syntax of the statement. Okay, if we run select star from EMP, what line process will read? It's a right syntax. Suppose if it is a select from star EMP, what line process will think? Can someone tell? Select from star EMP.
Wrong syntax.
Okay, client process will identify, it will throw some error. Okay, you have seen these messages. Okay, whenever you given wrong statement in the SQL prompt, are you getting one error or not? Are you getting that?
Yes, sir.
Means if the syntax is wrong, suppose instead of $v database, if you give v database, you are missing dollar. Are you getting the output?
No.
No, sir.
Okay, that is the wrong syntax. Okay, the syntax can be like if the table is not exist also, we get an error. Understood? Syntax is nothing but select from star is a wrong syntax. Select star from, it is a right syntax. The table existence is different. The table is available, then we get the output. The table is not available, we get the result like an error. The table or view does not exist. Did we get this error anytime in the past while practicing?
Yes, sir. Yes, sir.
Okay. The client process will do the syntax check. Okay. Client process will not check the table existence, the table privileges. It won't check anything. The purpose of client process is whether the syntax is right or not. Client process won't check whether the table is exist or not in the database or schema. Clear my point?
Yes, sir.
Done. So client process checks the syntax. The syntax is fine. Then it will update to the server process. What server process will do? Server process will do semantic check. The semantic is nothing but whatever the table we are reading, the table is exist or not. Okay. Whatever the table we are reading, the user has the privilege to access the table or not. Understood? So that type of
Yes, sir.
validations will be taken care by server process. Okay. From where it will pick? From where it will pick? Semantics will be taken from the data dictionary cache. Okay. Data dictionary cache holds the semantics information. Okay. From there, server process will pick the semantics. Then it will confirm whether the user has the privilege on the table or not. Okay. The table which we are searching is exist or not. This type of things will be taken care by server process. Clear until here? Any questions?
No.
No, sir.
Then here our statement is select star from EMP. Okay, select star from EMP. So here Oracle has to prepare the execution plan. Oracle has to prepare the execution plan. What is the meaning of execution plan? How this particular statement will be executed. Okay. Means suppose if you are traveling from one location to another location. Okay. How you are going? What is the direction you are going? Okay. So we will have like a number of ways to reach the target location. Okay. How we are deciding the best direction to go? Can someone guess? What is the factor we are considering?
Time and distance.
Time and distance.
Time and distance. Okay. If the distance is more, the time is less. Which you prefer?
Time.
Time based on time.
If the distance is very less, but if you go to that direction, it will take more time. The distance is more, the time is very less. Okay. So in that condition, which option you are going to choose?
Time is less. Distance is more.
More, right? You always prefers the time. Okay. If you don't have any consideration about the time, then we choose the distance. Suppose you have to reach to the destination at so and so time. Then you have to think about the time. You should not think about the distance. Okay, there is no time limit. Then what is the way you are going to do?
Shortest distance.
Shortest distance. Okay. Suppose RTC. Are they follow the longest distance or are they follow shortest distance?
Longest distance.
Longest distance.
Okay. So in our cab or in our vehicle,
Yeah.
we follow.
Shortest distance.
Shortest distance.
So based on the time, we follow based on the time. Okay. So RTC won't follow based on the time, based on the distance. Okay. So it won't based on the traffic also. Because it will reach to the destination at any point in time. We exactly don't know when the RTC bus is going to reach high-tech city. If we start now, right? Is it right? But if you go via cab, okay, or bike, we know where the traffic is. Then we can choose the best direction to reach the high-tech city. then definitely we will try to reach earliest. Is it right?
Yes, sir.
The
Yes, sir.
same way here, there is something is called optimizer. There is something is called optimizer. Optimizer has like capability to pick the best execution plan. Okay, from where it actually picks, it picks the best execution plan from the library cache. From the library cache. Library cache contains multiple execution plans for the statement. Okay, if you want to reach to the target destination, we have multiple directions, right? Is it right? Is it right what I am saying?
Yes, sir. Yes, sir.
The same way, if you want to fetch the data, it will have multiple ways to fetch. Okay, so we have different objects in the database. So we can fetch the data with index. We can fetch the data without index. Okay, so these are the options we have. Clear?
Yes, sir.
Yes, sir.
So depends on the query, depends on the situation. Okay, so optimizer will pick the best execution plan out of it. Optimizer will pick the best execution plan out of it. This is the architecture introduced from like Oracle 10G, 11G, 12C like that. Before 10G, we have to tell the optimizer to go and pick the execution plan based on something. Okay. We have to tell to the optimizer. We have to you have to pick the best plan based on cost. Let's assume. You have to tell that. Then the optimizer will pick based on the cost, not based on the time. Understood? So from 10G onwards, the optimizer is changed. Optimizer is picking the best execution plan based on the time, mostly based on the time. 99%, it will pick the best execution plan based on the time. These options were not there in the Oracle 9 version, Oracle 9i. From Oracle 10G onwards, the optimizer features are changed. 11G more changes, 12C more changes. Okay. There are no much changes from 12C, the optimizer. Clear? So optimizer picks the best execution plan from library cache, where the execution plan details are stored in the library cache. Okay. What library cache contains? SQL, hash value, and SQL ID. Okay. Let's compare with general examples here. SQL ID is nothing but target place. Let's assume the target place is high-tech city. Okay. Hash value is nothing but the direction which you are going. Okay. I am staying in Kokatpalli. So I want to reach high-tech city. How many directions we can go from Kokatpalli? Can someone tell who is living in the Hyderabad? Anybody?
From Kokatpalli to Maitrevanam to High-Tech City, one way.
One way. Okay.
Directly from Kokatpalli to like JNT to High-Tech City.
Okay. Then the third. Kokatpalli to Musapet. From Musapet to high-tech city we can go. Kokatpalli to Miyapur. From Miyapur to Kondapur. Kondapur to high-tech city we can go.
To
Right?
High-Tech City.
Okay,
Yes, sir.
these are the directions we have. So each direction has the separate hash value. Okay, hash value is nothing but actual execution plan. Understood? SQL ID contains multiple hash values. Okay, if the SQL ID picks the hash value 1, okay, maybe the performance is good. If the SQL ID is picks hash value 4, let's assume, the performance will be bad because it is picking the wrong execution plan. Hash value is nothing but indirectly execution plan. Okay, SQL ID contains multiple hash values. Multiple hash values is nothing but multiple execution plans. Clear about the hash value and SQL ID? Whenever you run select star from EMP, every statement creates with a ID. Every statement creates with a ID. That is called SQL ID. Under that, hash value will be created based on the execution plan. The hash value might be changed based on the different conditions. Clear? Any questions? Anybody?
Clear. Yes.
Next.
No.
Library cache, SQL execution plan will be taken by optimizer. Okay. So that is what we discussed. Then. So DBBC contains different types of buffers. One is like pinned buffer. 1 minute now. Okay. So DBBC contains different types of buffers. Okay. The first one is pinned buffer. Second, buffers which we are mentioning here, free buffers. Third, we are mentioning dirty buffers. Okay, there are 3 types of buffers in the database buffer cache. Pinned buffer is nothing but currently there is a statement running. The statement related data or blocks related content kept in these buffers. Okay, someone is reading the data from the database. Okay, then these pinned buffers are utilizing here. Okay, if you want to fetch the new data, these pinned buffers we cannot use it because the pinned buffers already used by somebody. Coming to the dirty buffers, someone is updated the transaction, like performed the update statement, performed the insert statement, performed the delete statement. Where the transaction is still going on, the transaction related data is not yet written into the data file. Still it is in the database buffer cache. Okay, the transaction is updated and committed, but not yet written into the data file. In that case, those buffers we can call it as a dirty buffers. So free buffers, no one is using. If you want to fetch the data, if you want to perform the transactions, the free buffers should be available. The free buffers are available, then only you can able to do the select operations, then only you can able to do the update or insert or delete, whatever it is. Okay, now in our case, like you're running select star from EMP, we need to fetch the data from the data file and keep it in the database buffer cache. From there, we have to give it to the client process. Okay, that is what the execution plan. The execution plan is your data is available here. Let's take an example. This is what our data file. Your data is available here. From here, you have to give the data to the client process. In this case, so from here we have to pick and copy to here. From there, we give it to the client process. Okay. Who takes care of this copying this particular content from here to here is server process. Same server process will be there. Okay. It will take care of copying the content from the data file and keeping into the free buffer. From there, it is giving to the client process. Okay, server process, the same server process will come and take this content and copy to here. From there, it will give it to the client process. The client process. Clear? Any questions?
No, sir.
No, sir.
So this is the select statement. Suppose I ran the select statement. Okay. It is reading from the data file. It is reading from the data file is nothing but it is reading from the mount point, right? Is it right? Where the data file exists?
Mount point.
The mount point. Okay. Where the mount point exists?
The server.
The Linux, right? The
Linux.
Linux server. Where the Linux server is installed? In the hard disk, right?
Yes, sir.
Yes, sir.
Okay. The hard disk we install. Okay. If you read the data from the hard disk, means from the data file. From the data file is nothing but from the mount point. From the mount point is nothing but server. From the server is nothing but hard disk. If you read from the data file, that parsing, we can call it as a hard parsing. Okay. Hard parsing. Let's take another example. The data is already present here. Okay. I am running the statement after 10 minutes. Now I executed the statement. Okay, I got the result. Okay. After 10 minutes, I am executing the same statement. Okay, do I need to fetch the data again from the data file?
No, sir.
Then how it will be retrieved? How the execution plan will be?
From database buffer cache.
From database buffer cache to the client process. Okay. Simple. Okay, you already reached your office location. Okay, you are already at the same place. If you are already at the same place, you can directly go to the office, right? If you are in the different place, you have to travel, then reach, then you have to go to office. You already reached there. Every day you are going from, suppose let's say Kokatpalli to High Tech City. At 9 a.m., you have to reach to the office. Okay. Today, what you did, you have some work at the High Tech City. You started early at 7 or 7:30. Okay. You reached within 30 minutes. The time is 8 a.m. Okay. But you need to go to the office at 9 a.m. Okay. Office will be opened at 9 a.m. In that case, like, will you travel back and start again from the source? Or will you directly go to the office? Which is the best?
Directly go to the office.
Directly go to the office. You understood the comparison? I am
Yeah.
explaining with the basic examples. Okay.
Yes. Yes, sir.
So if you do like that, suppose the buffer or content is already present in the DBBC, you are fetching the content which is already present in the DBBC. That parsing we can call it as a soft parsing. The parsing we can call it as a soft parsing. Soft parsing is more, your performance is more. Okay, soft parsing is more, your performance is more. So you have to think like in a DBBC, we have buffers. Buffers will be filled, right? Those will be filled, right? After some time,
Yes,
those
sir.
should be erased. Those should be erased. If the buffers are not erased, the buffers are not cleared, the new transactions will not work. Or new select statements or new retrieval from the database will not work. Okay, whatever the buffers are there in the DBBC, those should be cleaned up automatically. Okay, once a transaction is completed, okay, the data is written into the data file, automatically those buffers will be cleaned up. Once you retrieve the data, you executed select statement, okay, the result is given to the client process. Why we need the content in the DBBC? Okay, we can release that content from the DBBC, right? If you release that, these buffers will become free, right? Then other transaction or other select statement will use, right?
Yes, sir.
Okay, this will be cleaned up. Okay, so there is a concept is called FIFO. FIFO in BTech or MCA, okay? First in, first out. How many people know first in, first out?
Yeah, I know.
Okay,
No, sir.
whoever is coming first, okay, those people will go first.
Go first.
Okay, that is what. Okay, so soft parsing, hard parsing. There is some update statement. If you understand that update statement, you can understand entire architecture. Clear? So we'll discuss further tomorrow. One
Yes, sir.
technical concept we will cover, one theoretical concept we will cover in the evening classes. Okay.
Okay, sir.
Right. Good night.